Okay, so this is tutorial sheet 8 on pulleys and inclined planes. So quickly, let's go through question 1, which is saying, consider the Atwood machine, which consists of a rope running over a frictionless pulley with two objects of different weights attached as shown below. If the system is released, find the acceleration and tension of the system. So our goal is to find the acceleration and the tension in this system that we've been shown here. So the first thing first, as a physics student, let's bring down our free body diagram. So my free body diagram, I'll say is my frictionless pulley here. Then I have 20 newtons here. And I have 12 newtons there. Okay, so if this is my frictionless diagram, and they've told us to say it's initially at rest and it is released. So using your common sense, I'm sure you should be able to tell to say if this object or this system is released, it is going to accelerate towards where you have a larger force or a larger weight. So which means it's going to accelerate towards this left-hand side of our system, which means it will be going down like this. So if this is our free body diagram, what kind of forces do we have on this system? So we know to say there is a rope here, there is weight acting on this object. Even here, there is weight acting on this object. And there's tension in this string, tension here. But the directions of these forces, not to say it is going to accelerate towards the left, which means this weight which is here is towards the direction of acceleration. This weight which is here is against the direction of acceleration, which means the negative force. The tension here is pointing up like that in the string, which means this tension is towards the direction of acceleration. Whilst this one which is here, because it is also pointing up like that, it is against the direction of acceleration. So which means these two forces are negative. So let's bring down our equations with using Newton's second law of motion. Let's bring our equations on both objects. So if I say the forces acting on this object, the summation of forces acting on the 20 Newton object, I'm going to say they are equal to what? They're equal to mass multiplied by acceleration, like that. Indeed, the summation of forces, what kind of forces do we have? I have weight, and weight is positive since it's towards the direction of acceleration. So I'll say W, which is a positive force, minus tension. This is equal to what? This is equal to mass multiplied by acceleration. Okay, so I'll say this is equal to mass multiplied by acceleration, like that. And this is the mass of what? This is mass of the 20 Newton object. Okay. On the other side, we have this guy. So this guy, if I say the summation of forces on the 12 Newton object is equal to mass times acceleration, we're going to get what kind of forces? We have tension, which is towards the direction of acceleration, so it's positive, minus the weight of this object. This will be equal to what? This will be equal to mass multiplied by acceleration. So this is mass of the 12 Newton object. This is mass of the 20 Newton object, like that. Okay, so if these are our two equations, let's now put some values that we know. We have 20 as the weight minus t that we don't know. This is equal to mass. We can calculate the mass of this object, I'm sure. Since we've been given the weight, we'll say the weight, which is 20, divided by the force of gravity, which is 9.81, which is giving me 2.04. 2.04 acceleration, like that. Okay, and on the other side, we have tension minus what is the weight? The weight is 12 newtons. This will be equal to what is the mass of this object? The mass will be equal to 12 divided by 9.81. This is giving me 1.22 air, like this. So now that we have this these two equations, you can see to say we are missing two common things. We're missing tension and acceleration. Even here, we're missing tension or acceleration and tension. Like that. Because we have a system of simultaneous equations. So what can we do? We can actually solve them as a system. So what are we going to do? We're going to make either T or A in either of these equations the subject of the formula and replace it into the other equation. So here I'll say T is equal to 1.22A plus 12. So if this is T, let's get this guy and plug it where there is T here. So I'll say my 20 minus of my open bracket here. 20 minus 1.22A plus 12. This is equal to 2.04A. Okay, so this is 2.04A like that. Okay, so I have 20 minus 1.22A minus 12. This is equal to what? 2.04A, like that. Okay, so 20 minus 12, we can get 8 there directly. Then I'll get this 1.22A and take it to the other side of the equation. I'll get 8 is equal to what? 8 is equal to 2.04 minus 1.22. Actually, it will become a positive when it crosses the equal sign, and that is A. Okay, so 8 will be equal to 2.04 minus 1.22. It's giving me 0.82A like that. So divide both sides by 0.82. Then this side 0.82. We're getting our acceleration is equal to 8 divided by 0.82. I'm getting my acceleration as 9.756 meters per second squared, like that. So that is the acceleration of the system. Then since we found the acceleration, we can just plug it into one of these equations. So I'll use this same one. So we have 1.22A plus 12. We'll say our tension equal to 1.22. A is what? A is 9.756 plus 12. So our tension will be equal to my answer multiplied by 1.22. Okay, I'm getting 11.9 plus 12. I'm getting my tension is equal to 23.9 newtons. All right, so that's all about question 1. Thank you for watching the video. Kindly like, share, and subscribe to the channel. Thank you.